You can find this question in the textbook section 6b. And this is question A of the textbook section 6b. The question asks you to identify which of the following graph have a positive gradient, negative gradient, zero gradient, and not defined gradient. The positive and negative one are pretty straightforward. We know the positive one is traveling up from left to right, and the negative one is traveling downwards from left to right. Okay, so our positive one will be the line B, the blue one, and our negative gradient will be the one will be line A, the one in red. Okay, now if you look at our C, if you travel, if you look at from left to right, there's no left or right to it because it's perpendicular to the x-axis. And with our line D, when we look at from left to right, there's no change in there. Now, so it's a bit hard to distinguish which one has a negative, which one has a zero gradient, and which one have a not defined gradient. If we go back to our formula or the definition, our gradient means the change of y in unit change of x. So change of y in unit change of x, we look at the line D, there's zero change in y in the unit change of x. So when we go for the formula is change in y divided by change in x, there is zero change in y. So the change in y is equal to 0 in change in y. It doesn't matter what is change in x equals to, because the numerator is 0 and our change in x could be any number. So it's always going to be 0. Because it's a rational number, it could be any rational number. Or we can just plot 2 points on the graph. Let's say this one is equals to 1 and this one is equal to 4. So the change in y is still 0, but the change in x is equal to 3. So when we have a horizontal line that goes from left to right with no change in its elevation, so we can say that it has a zero gradient. So in this question, our line D has a zero gradient. The one that was left is not defined, but how do we prove it? If we go back to our definition of the gradient, so change in y over the change in x. The change in y, there's a lot of change in y, but there's no change in x. So the change in x is going to be 0. If we have a fraction with 0 as its denominator, then this fraction will not be defined, so it's not defined. Okay, so we can use the same method if we find 2 points that's on the graph. For example, I can find these as my point 1. This is y equals to 1, and here could be y equals to 8. My 8 take away 1 is 7, and 7 on top of 0 is not defined, or as any fraction we can represent that as a division form. So 7 divided by 0. So number divided by 0, the answer is not defined. Therefore, our gradient is not defined. Okay, so if you go back to our basic formula, the change in y based on the change in x, there's no change in x at all. So there's the gradient or the change in 5 is unspecified or is not defined, undefinable.